Start today's stream. What I'm going to do today, let me check this thing. Okay, closing everything. So let's start our application. Okay, it has started. We can emulate our value, our sensor data. So yeah, what I want to use here is to implement a video input placeholder. Okay, I should have some things ready. So this is the thing that will do the streaming. Okay, I think I'll focus on these values only. Okay. Okay. There is no image. There is no image right now in our application. Let's create some. Okay, it will be. I have some recordings which are empty files, and I will create some simple image. Let's open our image manipulation program. We'll create a new thing. Okay, let me check. Connecting to the Raspberry Pi. Okay, we'll check the history. So 1020, 1280, 1280, 720. Okay, just the same, just to use the same format of the image. Okay, and let's add some text here. Test. It will be like this. And let's move it somewhere into the middle of the page, and I will export it as okay. User projects. Okay. It's inside the here brief. How did I call that file? Image. Image PNG. Okay, let it be like this. It should be not very large file. discarding the changes. PNG. There is some output, but I think it just killed my output inside the terminal. Okay. Okay, so I have the thing. Okay. I think I will just use the thing. PNG. PNG. It's our file here. Okay. And why is it? It is unlisted. Image PNG. Okay. Interesting. Okay. Let's see. Let's stage it. Okay. And it seems it didn't work correctly. So this file was not tracked. We want state this, everything. Just everything. Okay. And how about this? Interesting. Okay. Its status. Okay. Now how about this? Status. Okay. Okay, so it should work then. Okay, add in some files and staging a git ignore file too. Okay, let's move to our CTV, to our stream, and what I will do is to replace this thing with our placeholder. Def video input. Okay, and what it will do, it will be using let me check. Okay, video input command will be like this. Video input command. Okay. Okay. What I will do here is to take this thing and by default will be this thing. Okay. Instead of this, I will be using something like this. Video input. Okay. And I'm going to add a little bit to here. And also brief. I will be dating recording path. Generate recording name. Okay. Recordings dir. Okay. Default image location will be code with dir and pass drawing. Okay, this thing is HPNG. Okay. And I will use it here. Default image location. Okay. ATV video command. Okay. So what it will do? Video input. Set a video input command or PC. Okay. We'll use static image by default. Okay. Commands. Video input commands. Okay. We'll borrow some from the Raspberry Pi. Okay. Capture video with speed till. Okay. So I have now speed command in my application on my PC. So this should work on my PC too. Okay. Let's see how it works. Let's emulate one. and 0 again. Okay. It definitely takes some. So, who takes most on CPU? Okay, it's our FFmpeg thing. Okay, and it's in hex dump somewhere below. Okay. So it should stop streaming in some time. Let it be like this for now. And let's copy this thing. And. Okay. And I will try to play the stream. Play RTMP localhost 1935 stream. Does it work? Not sure whether it works. No? Yes, no? Let's try starting it like this. Okay. So we have a stream on our Raspberry Pi. Okay. RTMP host 1935 stream. Okay. It seems it doesn't work. Let's stop this thing. Let's try to start it again and to see whether we will get some image. Okay. Not sure whether it works. So instead of this, okay. I just forgot to add a pipe. Okay. Dimensions not set. Okay. It's interesting. So okay. Which I have worked a little bit on it. Okay. Not H264. It works, I believe. So let's try adding this thing and see how it will work. Okay. X264. How about this? Okay, something happens. It should complain, I believe now. No. At least one output file must be specified. Okay. If do we have something like this? So yeah, we'll turn to Google a little bit. Static image. Okay, so I don't need this thing. Set the width height. Okay. Let's borrow some comments. Okay. CW lib x264. Okay. Okay. Copy. Video format be this. I need to add the format here. 264. How about this? Something happens. Not suitable output format. Output formats. Okay. Output. So MP4. Okay. Let it be like this. Will it work? No. Okay. Does it work? Okay. It seems it does work. Let's restart it. Okay. I have something, but it doesn't look like the image I have set previously. Okay, it's not the thing. Okay. Big formats. So MP4 doesn't work well. Situation. Let's try using something like move. Delete will work. Will it work? Okay. It starts the stream, but nothing useful. Nothing useful inside it. Okay. One, two, 8, 7, 2, 0. Okay. It should be larger screen. No. No. It's just the same. How to stop it? Oh. Okay, stopped it. Let's remove it. Thing. Okay, it's quite interesting thing. ffmpeg start rtmp static file image. Okay. F image. Okay. Do we have something like F image thing? So it should be image 2. Okay. Hello, NetFlash19. How are you? I'm fine. Just looking deeply into how to stream a static image, just to use it as a placeholder. It seems like it should work, but not really. Okay, how are you? I have a black screen instead of this image. Let me show you. Instead of this image, okay. I have thought about the programming, the home automation, and so on. And actually, I have remembered something during my weekend. It's this site. Okay, so actually it can simulate Arduinos. Thank you very much. Okay, so I have thought about programming for Arduinos and so on. So you asked me about how to program, which one to buy or something like this, and I think you can just use something like this thing. Okay, so it emulates actual hardware. You can add some LEDs. Okay, you can connect some inputs to some outputs and write your code here. So no need to buy any extra hardware, and okay, it's much cheaper, at least for Arduinos and other stuff. So let me share the link to this thing. Okay, leave it. Okay, send a link to the chat. I think it will be very nice just to get started. Possibly we can you can share some links to some applications. We can even read the code, possibly suggest some things. So I think it will be much cheaper and much more performant than trying to buy everything. So I had to buy all the sensors just to show during the stream, and you can try to write your code or something like that without even buying. There are a lot of different components here. I think it will be very helpful. And if something goes wrong, for example, we will try to connect ground to some power things, and it doesn't want to do something like that. Okay, so actually it can break your Arduino or someone else Arduino, and I don't recommend doing this, but on the, I'm not sure, but on the diagram or in the emulator it will work fine, and just continue to to do something instead of breaking everything. Okay, so I think it's a nice thing to have, and yeah. Okay, so what I'm working on right now is trying to stream some image file from local. Okay, I have an image, and I want to stream it to my server. Okay, it tries to do some streaming, but it doesn't work well right now. So yeah, possibly we'll try to MP4. Okay, no. Okay, and so, do you have any ideas what to do with it? Because I'm trying to Google some information how to work with it. Okay. This FFmpeg is quite interesting beast. Okay, I have some, so actually it should work. Okay, if I have some camera and standard solutions. Okay, and it can take some time to deal with new solutions. Okay, so I have this solution and it works on the Raspberry Pi. It works perfectly. So actually what's going on here? This part of the command, it just grabs the video from the camera. Okay, so this command is actually a program that takes the video from the camera. Okay, the next thing, it's this thing shows that our output will be an STD out thing. It's quite difficult to. Okay, so each program in Linux and in macOS and in Windows too, it has at least 3 files. Okay, so we can think about them as pipelines or just entrances. Okay, we have a main entrance in our building, in our application. Okay, and this entrance, we can use this entrance to go into our building. Okay, so, and it is called like std in. Okay, opening up GIMP thing. Okay, opening, creating new thing. So actually we can have a program. Okay. It's our program. Okay. It's our program. It has 3 things, at least 3 things. Okay, the first thing is something like input. Okay, it's input. So we can just type something and it goes into this part of our application. And it has also at least 2 exits. The first one is out thing, and the last one is error. Okay. I think, yeah, thanks for the suggestion. But sometimes it's more funny to type. Okay. Error. Okay, so actually we have something like this. So our input thing, our output thing, and our error thing. Okay, so each program uses these three things. They are called as streams or file descriptors. We have standard input, standard output, and standard error thing. And if we have, for example, two programs, okay, possibly I need to unselect this thing. Okay, it created another layer and push down. Okay. If we have two programs, it will be first program and it will be the second program. P2. Okay, we can have some input into the first program, I1, and we can combine them. So the input from the first program will be the output for it, and also can be the input for the next program, and so on. We can just E3. We can just pipe the input from one program to the output from one program to the input of the second, and so on. So yeah. And this command just means the same. We have a first program and we have the second program. It takes too much arguments. It's like a scary large string. Okay, so it's the first program. It has no input. Okay, it has no input, and the output from this one we pipe into the input of this program. We can combine these things to create some interesting stuff. So actually, what does it do? It opens a camera with this program and pipes the image to this one. So this program uses the image it took and also adds some music or sound. It actually nothing. So it mutes sound but adds some. So it's technically we cannot listen to this thing at all because it's a silence thing. So we just add some thing because streaming parts require audio and video. Okay. So it takes the input from the previous part, from the video recorder, and converts it to somehow and sends it to my streaming server. Okay, it's very simple one. So everyone can have lots of those streaming servers on his PC or somewhere where he wants to have these streams. Actually, it can be a Twitch URL, so the program I will use to stream my video and audio to Twitch uses very similar link. Okay, it can be YouTube URL, it can be some other URL. Okay, it uses just the format that all those applications understand. So actually the format is like a language. So my program, this one, okay, talks the same language as a streaming solution, streaming server. So yeah, and it can translate from the camera language to the language that understands our streaming server. Okay, so I have no such program on my local PC. I have it only on the Raspberry Pi. And I tried to replace it with very simple solution. So it should just create a video from simple image. Okay, it will be just simple image that will work like a placeholder. Okay, why do I want this? Actually, to be able to debug how it works, because I have no such program on my PC, and I need to debug, to work with it somehow, and to check that it actually works, because it's very difficult, it's very frustrating to see that you have a program and it should do something. You just follow every advice from the README file, you have prepared everything properly, but it doesn't work. It's very frustrating experience, so I'm trying to give some interesting things to work with it. Okay, so this part of the program works correctly. It takes something from the input and converts it to the proper format and streams it to some server. Okay, and I need to replace this thing. So I have found some examples. It's quite okay to use a Google with this thing. Okay, at least one output file must be specified. So regarding this thing, I think this output goes to std error, to the error stream. Okay, so yeah, we can use it for debugging purposes. Regarding the FFmpeg thing, it has too much configuration options, and it usually takes some time to work, at least with simple things. Okay, FFmpeg, not stream, but video from image. How to create image, video from images. Okay, I need only one thing. So sometimes programming takes some time to just find a correct solution for your problem, for your task. Okay. Okay, create it. Do we have some solution from it? Okay, I have only one image. Video from static image of still. Okay, creating loop 1 image. Okay, I have something like this. It's a duration. I have seen this thing already. Okay, let's try using this thing. How to copy it? Okay. So instead of this thing, we will be using image that device inside the prev image png. Okay. I have an output file for it. Let's go to the project, cctv, and output. Yeah. Why is it so small? Let's make it larger. Okay. 1280 and 720. Yeah, overwrite. Okay. Let's try this thing. xdg open out mp4. Okay, thank you. Thank you for it. Do you use this thing? Thanks for suggestion. Okay. So actually it works. It can create a file. Let's try to... thank you. It's very nice. Which distro do you use? Oh, MP4 is not correct thing. Okay, I'm using Ubuntu too, because okay, I am quite used to it. I think that for some people it doesn't work well, but it fits me. Okay, I needed to update. Okay, Ubuntu possibly, or Mint, or okay, I see. So they both basically are just from the derivatives from Debian. Okay. Do you like the XFC better than GNOME, than KDE? Okay. Sorry to hear that. What are your specs right now? Technical, I mean, of the CPU. I see. Yeah, I understand this. I tried to work on Ubuntu, and it's not so bad, I believe. I have something like this on my laptop too, and it works quite fine for most cases. So, as I understand, then you can use some programming languages, learn some programming, do something interesting. Okay. So if you are interested, we can discuss some programming stuff. I can share some my experience, okay, in some languages. I think you're using it for surfing the internet, okay, or do you play games on Linux? Okay. Interesting. And what I see. And do you learn it already program it? Is it your hobby or it's your primary work? Well, I haven't written C quite for a while because it was one of the first languages I learned in the university. I have some experience with it. It's very interesting how to allocate all those memory and try to delocate everything. I'm not very used to debugging applications in C. I see. I see. It's very interesting. So, do you learn this language or already just took some courses? I see. It's nice. It's very nice language because it can you can do almost everything inside it with C, but in some cases it takes much time to implement some stuff. Okay, but for embedded things like Arduino and some other microprocessors, it's just very nice language because it allows you to do almost everything. And actually you can, yeah, so that's why I'm mostly focusing on interpreted languages or something like this, because I love the development speed for them. In most cases they're not so efficient as C or C++, but I like them better because uh, they are more oriented to the developer. Okay. But definitely have studied and written some programs in C. Yeah. Sorry. Just touched the microphone. And which programs do you usually write in C? Is it some CLI applications or some stuff? I think it's very easy to create many things in C. Okay, and patch something and work with directly with memory. C is very powerful because it gives you access to the memory directly. So it can be a plus. I see. So it's like for your usage. Yeah, no, I mean using it like a hobby. So creating something. Interesting. So you want to create a new one, yeah? Or you're just interested in how HTTP works and how it should how it is implemented, all those headers and other stuff. Okay. Okay. Okay, so you're creating an HTTP client for C. So I believe you can use it inside your embedded applications, possibly even for something like this thing, ESP. So what is this chip? It can connect to the Wi-Fi and send some requests. It's okay. There are some ESP 8266. Okay, it's more older version of this, and ESP32 is more powerful chip. Okay, it's not so widespread, but it has a network stack. It has some libraries. Okay, and it can implement it. It can work like an Arduino, but it's not so easy to get started with it like an Arduino. I have programmed some ESP things. It was quite interesting. So I think using it will be very interesting. Okay. And just looking which the maxim, Uxin, so MPG. Yeah. Regarding parsing things, I love some features of the language I'm working on, because it's very interesting. It has something like this. Okay, so it can pattern match. Okay, I need to add extra. Okay, I needed to add extra thing. Big. So it can use some syntax to pattern match pretty much on everything. It's no. This language is much older than me. Okay, it's Erlang, I think. Erlang, and it's interesting. So just like this thing. English, it's from 1986, I believe. So yeah, it's it's older than me, and right now I'm working in Elixir thing. It's more recent thing, but it's like a more user-friendly API. It resembles Ruby. Okay, but actually it's functional language. So yeah, it has some syntax to pattern match pretty much on everything. So Erlang itself was created to work with network, with telephone, with phone lines, with phone communication, and it was designed for this, but actually works quite nice with server equipment with as a server. Okay, so as I understand, you're using C structs, yeah. So we can do almost like this, but using the language itself. So we can say that that we need. So actually, how to say it? Yeah. So why did I use it? It's not the one. It is not the most efficient or the most fast language. We have more languages there that are more efficient and fast. For example, those Go or Rust, they're much faster. C is even more fast, but okay. So why did I pick it? So actually, one of the first language that I used was C, then C++, then Java, then Python, then Ruby, then Elixir, PHP, JavaScript, and some other stuff. I have written some bash scripts, Clojure. It was my first functional programming language. It's interesting thing. Let me show its syntax. Okay. Thank you. So it's like this thing. Okay. So it can be quite scary from the first glance. When you have very large functions, it's quite scary to see lots of those brackets, but it feels natural after some time. So actually, Elixir is not the fastest language, and it's quite nice for embedded things, because you can create servers that no, I have not worked with Racket. Okay, what is this? Interesting thing. It's also like Lisp. No, didn't work with it. So according to it, here is define. Yeah. Okay. There is some Emacs Lisp inside Emacs, but I'm not so used to it. Just didn't want to dig too much into it. So actually, as I understand, it's a function and it's a list of arguments. So here we define the variable, if it's mutable or constant, with the name of English. Possibly it's an atom or something like that. Okay, here we create a hash. So key of this, and okay, so it is a separator, as I understand, and this is string. It supports UTF-8 characters, and okay, href translations, my language. Okay, so I think it's my hello world. Href translations, my language. Define href. Okay, so this we take a dictionary or hash, its key and default value. Okay. So we take my language. Okay, we just get a key from this. It's our key, and default value is hello world. And we create a message box somewhere to show this thing. I think it's quite a readable thing. Interesting. There are too much languages. Yeah. So try to focus on those languages that I need. So yeah. Yes. Factor. Observer. Okay. So actually, I like the language Elixir for observability. We can connect to it to see how it performs, how much processes it has, how much memory allocators it uses, what the applications are started. So actually it's our application, and we have some processes. So generally you can yeah, I think so. So it's just a built-in thing. It has already possibly 10 or 20 years, and some people use it for those things too. So actually the general idea is everything inside the application is a process. Okay, so this is a process with some ID, this is a process, and other stuff is also a process. Okay, so some processes are specific process like supervisors. Okay, we have a supervisor and it watches child processes. They can be also supervisors and so on. So it's like a tree. Okay, and what supervisor do is just check that every process works okay. So if I try to kill some process, okay, actually it was killed and restarted again by the supervisor. Okay, so it gets a clean state when starts again. So for example, we have some error inside some deeply nested process and it fails to work. So the supervisor just restarts it and everything should work again. So basically it's quite nice feature for long-running applications like WebSockets or some other stuff. And also it was a nice feature for phone applications. Okay, so when one person called another and it was some error inside the application, inside the code, so the phone call just got interrupted for a fraction of second, and so a new connection was created and phone continued to work. And this thing is also useful for creating some embedded applications. For example, I have created something like this. So I have created a supervisor. I have created one process that is responsible for cleaning the disk. For example, if I have too much recordings of video streams, this thing will just clean my extra data. Okay, another process is responsible for looking for a motion sensor. Okay, so when I get some data or when I have something that triggers my motion sensor, this process gets notified. It understands that something happened and it needs to do something. Okay, this thing is another process that starts recording. I didn't pick the most suitable name for this. So yeah, it's a recorder. So let's return to it a little bit later. So, and this process is our stream. It is responsible for starting stream and for stopping it too. So this process is responsible for starting this stream. I duplicated the logic a little bit. So when motion is detected, this process pings or kicks this process that something had happened, and this process kicks this one. Okay, this process is responsible for streaming. It tries to stream so hard, and when motion stops, this thing tells that motion has stopped. So this process just yeah, it's virtual machine. It's like an operating system. It has own processes and so on. So actually, yeah, it's a virtual machine, but not Java virtual machine. It's called BeamVM. So every language that runs on Beam, like Erlang, Elixir, and other languages too, like Gleam, like Lisp flavored Erlang and other stuff, just able to run on the same virtual machine inside it. Okay, so this process also delays the end of the stream. So for example, we have a signal that motion has ended, and it continues to record everything until this process stops the stream. Okay, so when extra motion was detected, it just cancels the timeout and doesn't do anything to the stream itself. Okay, so this is pretty much the architecture for this project. Okay, so there are all the processes that are running inside our application. They are very lightweight, so each process is represented like a C-struct. It has only a memory and some pointer to the instruction which is running at the time, and something like this. So yeah, we have this, we have some extra things, so we can see. Okay, it's more interesting thing. Let's try to kill this process. I'm not sure whether it will work correctly, but let's kill it. Okay. It's a pity. It got killed. For real. It was not restarted. Possibly it was intended thing. So it's up to the developer how to operate with those things. Okay, let's try to kill some extra process. Yeah, I like it too. So there is a very similar debugger. It works only with Erlang properly, not in Elixir. Okay, it shows the code, but you need to write in Erlang to make it work correctly. You can see the values for variables. As you see, I have stopped I have killed this process, and okay, I have killed it brutally. There are different types of how to kill the process. Access home HX server. So it is the application, okay, that I developed before the CCTV solution. Plan to return to it a little bit later after it is implemented. Okay, and we can start an observer for it to start. Okay. it has more things. So actually I believe, or let's just see what is this. Okay, so this thing is our server. So, and each of these processes that are supervised under it are the listeners. So they can handle so much connections. So when someone tries to connect to our server, it connects to one of those processes. So each connection is a separate process. We can try to kill it. Let's kill it. Okay. It got killed and it just got restarted. So yeah. And I did something like this for the application for CCTV. So each process is just responsible for something that we need. Okay. It also has some in-application debugger thing. So you can set a breakpoints inside the functions and do anything you want. Actually, it also has some distribution. So you can dashboard thing. So yeah, it have a distribution. You can connect 2, 3, 4, or how much do you want nodes that run Elixir into the cluster and connect to any of those nodes. Run commands inside them. Just connect remotely to running system and patch some code. Okay, and it should work. So we're looking at the thing that is supported by the web framework. It's Phoenix thing. Okay, it's like the observer we have seen previously, but it's a web alternative for it. It's much simpler because it's not so safe to provide everything that we have in observer for a remote access, for a web access, but actually it works. Okay, so we can see some stats for our application. We have only 332 processes right now, and the whole application takes about how much? Where do we have it? Okay, so it's about 50 megabytes of RAM. Everything that we have inside it, those 300 processes and extra stuff. So yeah, just it's like a hobby to program in it. So regarding the code I have written for my application, okay, so this is responsible for streaming part. Okay, here we create a new server, new process, and so this thing module here, it means it is get replaced at the compile time by this thing. So when I want to rename this module, I will not need to change all the occurrences inside the module itself. So how Erlang and Elixir operates? each process is a separate thing. It has read-only memory, mostly read-only, but from the language itself it's read-only. Okay, so and each process communicates to each other only via message passing. It's like actor model. So yeah, so something like flash. What does this command do? It just shows my message box of the current process. Our shell, where I'm typing to, it runs inside the process. Process info. Okay. So we can see what's going on inside the process. We can introspect every process. Process list. Okay. Okay. We have 326 processes right now. Okay. So we can introspect every process, see the data from inside it. So it's not very safe to do something to give so very much access from outside to the virtual machine, but from inside the virtual machine you can just go into something that you want and use it for debugging purposes or some extra things. Okay, and we should have something related to messages. Process. Do we have something about messages? Okay, it's dictionary. No. No. Let's try to send some message. Send self. Okay, I have sent some message to self, and if I flash the data, it shows that I have some message inside the mailbox. So, and each other parts of application are built on top of this thing, the message passing. So when we use something like this, we create a new process. Okay, so gen server, it's a generic server. It's an it's like a framework or very useful abstraction on top of message sending. So it is our module. Okay, I'm not able to navigate inside it. It's our module, and it has a function that names, which has a name of start link. Okay, we pass it name of the module, some options, and extra options with this. So this option has a name of name and value of module. Okay, so what's going on inside this function? It starts a new process, it runs some init thing, actually this one. Okay, and according to, and it processes the response of this function and returns some result to the process that started this one. Okay, but it's hidden from the developer in most cases. Basically, what's going on inside it? It starts a new process, and yeah, it is not connected to us. The next thing is a client API. So each process can be considered like a server. Okay, like a web server. It has some requests, and it responds with some data. So we can we can consider this one as API call to our process, to our server. So what do we send here? We send start streaming item. It's like a keyword or whatever it's called. Okay, so we can send a start streaming message. We send it to our process and we process it here. Okay, by this thing we send a stop streaming command to our server and process it by the end of the file. Okay, slightly lower. So when we can also send this command to our service, to our process, and all those commands should return some response. Actually, there is extra parameter here. It's a timeout. Okay, by default, timeout is 500 milliseconds. So if server does not respond within this timeout, the process that called this, so actually it will get some error. So okay, this process can run on my node or just somewhere on the another server. Okay, so yeah, because of that we just doesn't look. So we will not be waiting for eternity unless we do something like, okay, in this case we will be waiting for eternity before the, so we will be waiting until any response is until we receive any response. Okay, so it's a client API, and this part is a server API. We can call it like this. So we have an init callback. It gets called when we start our server. We can do some setup inside it. Okay, so what we do here, we just return an OK, that everything is fine, and return something like this. So what does this part mean? It's like a map or hash or dictionary from other languages. Without it, it will be just a dictionary, and with this thing it will be like a structure. Okay, let me show you what does it mean. Okay, so we can create a dictionary by this thing with some parameters. Okay, and we can create another dictionary, ECTV stream. Okay, with something like this. If I try to pass some invalid parameter here, it will complain and fail with error. So actually it's like a typed dictionary or object from the object-oriented languages. So I have created it to store the parameters I need with its recording name and process ID of the actual recording. Okay, by default it is empty. The next thing is handle call thing. We have quite a couple of those handle call. So yeah, and it has like overloading of function headers like in C. Okay, as you see, we have many handle call functions here, and each one has own type of what it gets. Okay, so this body of our function will be called only when everything that we need, only when we get everything that we need. Okay, when the first argument will be this item, we don't care about what will be here, and we should get something like this as a third parameter. It's our current state. Okay, we should get the state with empty recording process ID. Okay, so if everything is alright, we proceed to our function. So we will generate a recording name, we will create a path for recording. The next we will start a bash or possibly bash script for recording the okay, so I just created it to fill some data, fill some random data into the recording file. Okay, so previously, let me show you what was before. Okay, it was cut dev random thing. So let me show you what does it mean. It's quite ugly thing. Okay, it just generates random bytes. Okay, it is not responsible. Kill pain. Okay, no. Yes, pain. Just recreated the panel. So cut dev random, it was just before this thing. Okay, returning it back. So it generates a string of, it just generates random data. Okay. Hex dump, it let me show you. It will be more easy to understand this way. Cut your random. Okay, pipe it to hex dump. Okay, so it converts it to more or less readable thing. Okay, it generates some data. Okay, the next thing I'm doing with this thing is greping for zeros. Why do you do it? Just to limit a number of what gets into the file. So it's generate. So this command generated some dummy data. So it generated some random things, and just not to store too much data, because about 2 or 3. Let's just see how much data it generates. Okay. So I started this command, and okay, where is my SDF? So after 2 or 3 seconds, it generated 156 megabytes of data, and it was too much. So I just used this thing also to limit the number of things. So instead of, so just to limit the flow of random data. Okay. And also deleting this thing. So it was just generation of dummy data. The next thing, I created a string, very long string from all those parts. So actually it's, as you can see, it's a list of strings. We are using string interpolations here. This is a string too, and we join those strings by space, by single space. Okay, and the next thing, we are piping it into the command. So let me show you what pipe is. One, two, I like it very much. Okay, and join. Okay, so we can do something like this, and we can use slightly different syntax for it. 1, 2, okay, and pipe it into the num. We can see that the result is the same. Okay, if we have too much things, too much functions to call with the data, if we write it in such way, it will take very much, it will not be very readable. If we try to format it, it will have some padding or something like that. And yeah, the more data you have, the more padding you will need to work with. And here we just pipe. So it will be the first argument for this function, and the result of this function, of the call of this function, will be the first argument of this function. So this thing is the second argument, and this thing is the second argument for our function. So actually we can pipe quite much of things. For example, something like this. So we creating a list, we join this thing and doing something with it too. Okay, for example, here we generate a recording name. So we take a local time from our PC, Raspberry Pi, and something else. Okay, the next we convert this thing from Erlang to our internal data structure and internal structure. Okay, and here we format it with the correct way. So actually it will be year, month, day, and hour, minute, seconds format. Okay, so let's see if we have everything that we will need. Okay, for example, we have a start streaming thing. We don't care what's from whom this request. Okay, and we have some state. If everything is okay, we will go into this thing. If our parameters doesn't match, then we will go here. Okay, it also has a start streaming. We don't care about from, and we don't care actually about state, but we pattern match on it and pass it like a last value of our tuple. Okay, so if this thing didn't match, then we will try to do something with our function. Okay. Okay. Is it interesting? Or actually, I think trying to do something with FFmpeg is not so interesting than discussing how it works. Okay. I just like doing something in this language. Okay. Okay. So there is no encoding, recording is started, then we start a recording. So actually they're very interesting stuff. Actually Erlang is written in many languages and some part in C2. Okay, it uses lots of define. No. GitHub. So. No, it's documentation for it. It's written in Erlang, so I think it's scripts person. No. I believe something inside these files. No. So it's the runtime system. Common. Okay, so it's some C sources for the virtual machine itself. It's quite lots of code for those 36 years of development. So it's quite battle-tested thing. Okay. The idea of separate process, also we can use something like this in. Okay, the actor system is also inside this thing. It's built inside the Scala thing, if I remember correctly. Okay, so the inspiration from it is drawn from Erlang itself. Okay, and okay, something like this too. So it's also actor model for Python. Possibly it something like this. Ruby also has something like this. No, actor Ruby lang. No. So I think pretty much every language has something like this, but this thing is just the core of the language itself, and I believe it more covered with some extra tastings. Yeah. I liked programming Ruby. It's quite. I had some experience with Rails, with how did it call? Okay, with Sinatra, I think it's like a very small DSL for writing server-side applications, and Ruby on Rails is more like very large framework with extra things. I liked the performance, about how it was very nice to work with it. Okay, and it doesn't scale very well. I think, yeah, it scales, but you need to add more servers to make it more scalable. So yeah, I think it depends on the deployment process, but I like inside the Ruby on Rails, I liked the think of libraries. So actually adding some. Okay, I think I will stop streaming for today too. Possibly will look into working with FFmpeg just just on my own, because it's not very nice thing. So yeah, have a nice rest of your day. We'll continue tomorrow. Bye.